So I read section 7 of Gallian, and then also did the first 25 problems. Amongst these problems, or attempted, there were 11 proofs, so I'm up to 213 proofs, 442 problems, and I'm at 26.2% of all the problems in the book. This is all about Lagrange's theorem, cosets. Yeah, cosets and Lagrange's theorem. Very good examples by Gallian on how to do the cosets. You just take the set that you're given, and you apply every member of the group, and then those are your cosets. And quite often they repeat, and so you get multiple cosets to be equal. And of course, the total number of cosets is, by Lagrange's theorem, the order of the group divided by the order of the set that you're making cosets out of. Some properties, they're proven with examples. And what I really like that Gallian did is not examples. I'm wrong about saying that. Is he does the proof, and then he rewrites every one of the properties in common language. Very useful, I found. More examples. And then Lagrange's theorem with a bunch of corollaries. Group of prime order is cyclic, for example. Fermat's little theorem. So there's some number theory callbacks. Then the converse is false, explanation of why. Then this part about combining subgroups, two subgroups, and combining them, and then figuring out what the order of their intersection is. This is done a little more with more content in Dummett and Foote. So actually, for one of the problems, I ended up reaching out to Dummett and Foote to look into it. I'm not going to show Dummett and Foote. I'm going to keep going. Yeah, and then classification of groups of order 2p. Then orbits and stabilizers, and their orders multiplied equal the order of the group, and that's the orbit stabilizer theorem. Then an example of the buckyball or soccer ball and the cube. By the way, there is a really great book by one of the guys who won the Nobel Prize. It may have been Smalley or Curl. I don't remember the name, Croto, that I read like 25 years ago, and it was awesome. I'll try to find the reference, maybe even find the book somewhere, although I probably gave it away in one of my moves before I started working. Okay, so it's just these 25 problems right here are the ones that I attempted, and I'll show them. And I found an error, a minor error in the exercise book. The exercise book has turned out to be a little sloppy. I don't believe Gallian worked out those problems. I think somebody else did, and they just didn't mention, the ghost author. That's my opinion. It looks that way because, Gallian worked on has been working on these books for eons. Okay, so reading chapter 7, of course, as always, I always work out everything in the book as I read it. So in this case, for example, they only show the left cosets. I went ahead and I calculated the right cosets. You just multiply from the right, or operate from the right. And this is what I just showed you from the book. But I like to add my figures every now and then and do some more than what, calculate through whatever is in. So I calculated all the cosets, for example, 4 from the left. They only show a few. I'm finding, of course, that you can never do enough linear algebra or number theory to get started with abstract algebra. I'm going to say that as a statement. I'm going to make that statement. I feel that way. Yeah, try to use my own example. And then try to use my own example. But here I got stuck in the way that I built D3. I just couldn't do the mapping correctly. But I did get the S3 to GL2 Z2 mapping correct. This mapping is correct. So if you take all the members of GL2 mod 2, all these matrices, and you take S3, you will be able to find a mapping where, and of course I just label them A, B, C, D, E, F. So each matrix, if you map it to each one of these elements in S3, you're going to get an isomorphism. So I worked that out because I wanted to. This is not in the book. I just wanted to do that. And I also worked through the orbits and the stabilizers, all of them, to understand the way the book worked out this example 8. I just couldn't tell what those dots meant. So I actually had to go and work them all out to understand. Yeah, the book could have explained this a little better, in my opinion. And this is done really well in the book, so that's great. Then I started working through the problems. Basic calculations got sloppy. I missed some terms. I did not understand the terminology that they were going for in these problems, but I have the answers, so I could say, okay, fine. And I got confused. It was not 15 cosets. It's 15 members, 15 elements, and then that sets the order. That's the denominator, and it's really 2. There's 2 cosets. So I got that wrong. And some of the proofs, I did my own proof, and it was different from the one in the book, and I didn't challenge the book, the answer book, and I gave myself a half, even though in some cases I believe my proof is correct. Yeah. I gave myself a half for this problem because I went into dominant foot and saw an example. I was like, that's kind of almost like cheating. So, but yeah, once dominant foot showed the example, I was like, oh, I see what they mean. And then I came up with my own example that's different from the one in dominant foot. Yeah, and here it is. There's an error in the book. In the book, the order of the group, the order of the group is 12, not 24, and there are 4 cosets. So 12 divided by 4 is 3 left cosets, not 6. So this answer is incorrect. There's no way that it is correct. It's a pretty simple problem. Got a proof correctly. Got another proof right. Just wonderful. Of course, my answers are always the world's longest answer, but that's just the way that I roll. Yeah, messed up 2 little numbers, but I was doing the right thing. I'm fine. And the possible order is 84 and 210 for this problem. This is an even problem, though, so there's no answers. But you can figure out what the orders are by starting from the group and then one of the subgroups. Yeah, I did not use corollary 3, but I think I got this proof right. Easy calculations for number theory. I gave a number theory proof to D sub n has a subgroup of order 4 if and only if n is even. But I'm not sure it's correct. The answer in the book is very elegant and well done, so I just wrote it out. The same from problem 25. The answer in the book is really elegant, and I went on and on about the rotation subgroup of D sub n. But I believe my proof is also correct. You just proved that this product, the product of all the rotation terms, is R0. And I believe this is correct.